2.
1, 2, 1, 2, 3.
You want to count to 10 or something in there? What number are you?
Number 3. Test, test. 1, 2, 3. Oh, okay, I'm here as well.
1, 2, 1, 2.
Hello.
Okay, so hello and welcome to SMTconnect on day 2. I'm delighted to be joined by Ollie Terrace from SMT Renting to my left, and we have the Managing Director of INCAP in Estonia.
My name is Greg Chris.
Greg Chris, okay. So nice to meet you, Greg. Both of you are celebrating a new announcement that you've made just today at the show. Maybe, Ollie, you can tell us a little bit about the announcement regarding the facility in Estonia.
Yes, thank you. Thank you, Trevor. We have just signed a new contract with INCAP, which we are very happy to have been our customer since 2017. This is the 3rd line we're going to install now, and we have upgraded the line accordingly. I would say every 2 years, basically, we have upgraded the lines according to the growth, which is with INCAP has been having over the years.
Yeah. Okay, and so tell me, why do you see the renting strategy? Why does that fit your business model?
No, I think it's great. We used to own the lines that we had, and it's basically you buy the line, and when you have it, you have the best line. 5 years later, you have a pretty good line, and you keep that line for 10 years, maybe more, and you're stuck with what you've invested in. But with the rental setup that we have with SMT House, actually, Ola mentioned, we started in 2017 with a line setup. We have since added a larger oven, changed the printer, added an SPI, added a better AOI. You can just stop and swap with their solution. You can continue to improve the lines.
Right.
And today we signed a deal where we're improving our 2017 line. We bought our 2nd line in 2020, and we're improving that line, making it faster, and adding a 3rd line so that we're going to we increase our capacity by more than 50%.
Right.
Adding robots on and changing some of the solutions that we have. I think that's the way to go. I mean, it's like leasing a car versus buying a car. Do you want to keep it for the rest of your life, or you want to swap it out every 3 to 5 years? Right. And so our possibility is to swap it out after 5 years, or continue with the agreement, or upgrade it. Okay. It's a great solution.
Right. So what do you? What kind of products are you typically making? What's your product mix like?
We do a lot of IoT and power electronics. We have, basically medical electronics. We produce a product that's going to the moon. We do small batch, large batch. Our line setup is for high runners, but we are a high mix, low volume, high mix, medium volume factory. But we do have the high volume, high runners. And so the 3rd line we're adding is actually to help our main lines run the high runners more effectively, and we'll have a line that can deal with the smaller batches more effectively. But we basically, INCAP is in all sectors, so we have other factories in India, the UK, and Slovakia. In Slovakia we have automotive, in the UK we have the AS aerospace and defense, and in India it's more power electronics. But we're in all the electronics sectors today.
I saw your results last week. Quite incredible growth. Was it 41% growth year on year?
That's correct.
That's massive. Absolutely massive.
Something right.
Is one of the reasons that this business model is attractive to you because you don't necessarily know what you're going to be making in 6 months' time, and you have some flexibility to be able to change the product mix?
Very good point. The first line that we signed was based on a customer that had a real need and said we need to do this. And we are a contract manufacturer, so we have the projects changing through the years. And as a new customer comes in, the advantage with SMT House is we can expand the line, plug in a new add-on that we need to be able to offer the capability that we have. So it's no longer about capacity or capability. As we're talking about, we're adding more robots to increase the capacity, or we can add on the capabilities as we have them, just for meeting our customer needs. And that flexibility, agility, is what our customers love.
Right. It's really interesting. So, Ole, I mean, are you seeing a growth in general in this type of business strategy?
Yeah, definitely. Over the last years, I see definitely a clear move in this direction, and we have our customers all over Europe, and we are getting close to 100 contract customers all over Europe in the near future here. So it's definitely, this is making more and more impact or impasse on the EMS companies, and it's more I would say the bigger customers who want to have this kind of fleet management of their SMT fleet. So definitely this is, and we see also that, as Greg just is mentioning, if we look to all the contracts, basically we see that all our contract is turned within 24 to 36 months. So something is happening inside that customer. New customers are coming in, growing, or changes, technology is changing, and we simply just stop and swap the equipment around to meet our customers' demand.
Yeah, I guess that probably must give you a little bit of a leg up in some of your competitors, because typically the model in Europe versus Asia is that, you know, in Europe and US they swap out machines in onesies and twosies, you know, in the line, whereas in Asia they tend to swap out the whole line. But you know, you're only as fast as the slowest machine on your line. So I think being able to have this agility is probably a good thing.
Yeah, that's definitely one of our USPs.
Yeah. Great. Well, there you go. Congratulations, gentlemen, on your agreement. And to our audience, that's the first big deal we've heard about here at SMTconnect. And I want to thank you for coming in and joining us today.
Thank you.
Time 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Hallo?
Okay, and welcome back. Delighted to be joined by friend and colleague, actually, Tanya Brown from Fraunhofer Institute.
Okay.
Nice to see you, Tanya.
Yeah, thank you.
Yeah, so maybe you can tell us a little bit about some of the work that you're doing at the moment at the Institute. You're basically the manager of the advanced packaging integration area. What's going on?
Yeah, so as an institute, we're doing advanced packaging, and I think technology-wise, we're doing a lot of embedding, and really we're studying heterogeneous integration also for these embedding, but also for chiplet approaches and antenna integration and all these topics.
Right. Okay. There's a lot of different technologies going on there, but a lot of this is surrounding the work you're doing for 5G and boards like this. Is this the areas that you're working in?
Yeah, I think there is a lot of developments, innovation in millimeter wave RF packaging with new materials, but also new packaging concepts with passive integration and also 3.5 semiconductors mixed with silicon germanium. There's really a lot of new things ongoing.
Right, okay. Talking about the heterogeneous integration, I mean, that's an area where you're trying to get all the materials within the package to be compatible, essentially. How do you make that work? Because a manufacturer of materials knows well how his materials interact with his own underfills and encapsulants, but not necessarily with other people's.
Yeah.
Can you explain to me how that works?
That is the R&D development work we really have to do, and I think it's also that we see a lot of new materials because we also see different applications, has new demands. Again, low loss materials for all these millimeter wave packaging, but we really have to fulfill different demands. So if you have 3.5 semiconductors, then we have maybe gold as an interface, which has to stick to the encapsulants, to adhesives. That is different as if you have silicon. So that is really what we have to bring together and really optimize, select materials, maybe also discuss with material suppliers.
Right.
Yeah.
So there's a lot of work involved in that, that's for sure. Yeah. Great. You've also been, thankfully, been working with us on the committee for the low temperature soldering conference, of course. And that's a growing area, and there's people using low temperature solders for different reasons. What is your view on that market?
We're also using that because it is an option also to have, especially for system and package, when we have different solder levels or assembly levels where we have to stack components, and then that could help that you have lower melting solder in that different hierarchies. And of course, we have colleagues who are looking more into the energy saving green electronics. That might be definitely also an advantage.
Yeah.
But I think there's still a lot of R&D to do to better understand these systems, also in combination with surfaces, but maybe also in interaction with standard tin silver copper solders, for example. Maybe sometimes we even did that combination because we got area array components which already had solder balls and these things.
Right. Yeah. I mean, there's a lot to unpack there and get to understand. But as you say, the sustainability is driving people to want to use less energy. And it also increases the reliability of the electronics, of course.
There's also a lot of discussions and also on the repair and reuse of electronics ongoing. That might be also interesting to have lower melting solders also for repair and maybe exchanging components for reuse of mobiles, but also of tablets and things like that.
Right. I mean, one of the issues I find that might be a thing for LTS is the fact that most of your grid array products are using standard SAC 305 in the balls and which obviously reflow at a much higher temperature than the low temperature solders. So is that potentially an issue?
Honestly, we still don't know. We have done that because we had no other way to build samples in that way, but we have looked a bit into it, and it's a quite complex solder structure, especially depending on maybe the later temperature you still apply after soldering. And if we do the components by ourselves and the balling, then of course we can already choose also low melting temperature solder balls, and of course that is maybe one strategy and not. But if you have to buy components from the markets, I think typically you don't have a choice. So.
Right. Okay. Well, it's always good to sort of catch up with you and find out what's going on at Fraunhofer. And I want to thank you for all the help you've given us on LTS and coming in today. Okay.
Okay. Thank you very much for being.
Thank you. Okay.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
sintering is essentially just
And welcome back. My next guest is Jian Dutt, who's the Global Portfolio Manager for Power Electronics at McDermott Alpha. Welcome, Jian. Nice to see you. Thank you for coming in.
Thanks, Trevor.
Okay.
Great talking to you again.
Yeah. So we're going to be discussing the topic of sintering today. Sintering is a technology that's been around for a long time, as we just mentioned, but it's having a resurgence. What is behind the sudden resurgence in sintering as a technology?
That's an excellent question, Trevor. Well, if I have to pin on one big thing, that's a big mega trend of electrification of transportation. Okay, so sintering, as you said, has been around forever. But what we have figured out over last few years is to do sintering at sufficiently lower temperatures and benign pressures that can withstand, that the semiconductor components, these fragile dyes, gallium nitride, silicon carbide, and silicon IGBT dyes can withstand those temperatures and pressure, where you can do these processing at temperatures which are far below the melting point of silver or copper, and the joint that you get lasts 10 to 30 times longer when it comes to power cycling, has thermal resistance, which is 1/3 or 1/4 that of solder, and much higher efficiency, much lower heat dissipation loss. So that your car runs longer and lasts longer, and that's the name of the game.
Right. Okay, so it's really extra reliability and better thermal and performance, really. But one of the things with sintering in particular is that it does have a capital equipment component to it. You do need to outlay for these presses to be able to do it. Do you find that a bit of a barrier when you're talking to companies about it, or are they're convinced already about the process?
Sure, Trevor. So we essentially worked with our equipment partners over last few years to develop the ecosystem where there could be multiple sources of equipment which could do the kind of processes we want to. So we have been through that cycle over last decade or so, and then now we have come to an inflection point where you have multiple suppliers who are producing ready to deploy mass manufacturing capable machines which can handle sintering. And if you were to make that investment in alternate technologies like soldering, they're finding that with sintering, with fast cycle times, you are able to process a lot more parts. So actually your cost of ownership is lower than processing the same things with solder, even though the cost of material might be more expensive in itself. And at the end of the day, you have to pay to play to get the kind of benefits you want to achieve with sintering.
So obviously then it's suited to a high volume environment where you need the throughput, basically.
Absolutely.
Yeah.
So you could process the cycle time is of the order of a few minutes, a couple of minutes. When you bring the parts together, you heat them up, you press it, and boom, you have your component, versus soldering where you have to wait for like upwards of 10 minutes with all the reducing atmospheres and all the nasty things that go with it. So it's a fairly rapid and and user-friendly process.
Okay. So what sort of alloys do you work with when you're doing sintering?
So essentially, right now, the incumbent material or the material of choice is silver. Okay, so
Is silver?
Silver, exactly. So
Well, that's expensive. I mean, of course, you're going to get the best conductivity with that, but I mean, it's pretty expensive.
So silver is, sort of an ideal material from die attach perspective. It has very high melting point, upwards of 900 degrees Celsius. It has very high thermal conductivity.
Yeah.
It has very low electrical resistivity. So you combine these things together, and then you have a material which is ideally suited for attaching these fairly expensive silicon carbide and gallium nitride dies. So if you are paying 3 times the cost of your die with silicon carbide over silicon, you might as well go with the better solution for attachment and get the bigger bang for your buck, right? So that's the idea. So silver is the material of choice when it comes to sintering.
Right.
Lately, there has been some interest in copper-based materials, and they are a subject of a lot of investigations. So
now, when you talk about copper, are you talking about nanocoppers, or are you talking about?
So there are different versions around, right? So the challenge with copper is, of course, oxidation, right? And the smaller you go, more surface area you have, more challenges of oxidation you have to overcome. So there's a balance based on where you want to go. Okay. So people are investigating a whole set of materials, but right now I believe silver is here to stay.
Right. Interesting. Well, it's I know that most of the big car manufacturers are using it, so that's testament to the technology, and it's always interesting to learn more about it. So I want to say thank you very much, Jan, for coming in and talking to us about it today.
Sure, absolutely. Thanks, Trevor, and I enjoyed talking to you.
Thank you. Okay.
Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy-hungry and inefficient, expensive and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge. In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
And welcome to Live at SMTconnect on Wednesday afternoon here in Nuremberg, Germany. Thank you for joining us. My first guest today is Ralph Birnbaum from IoTech. Welcome, Ralph. Nice to see you.
Thank you for having me.
Yeah. So, you released at Productronica last year, I think one of the most fascinating technologies I've seen for a long time. The system basically is a combination. It could be a dispenser or a jetter, but basically it puts down materials in specific amounts very, very accurately and very fast. Explain to our viewers a little bit about how it works.
Yes, thank you, Trevor. So in fact, the people at Productronica also thought it was good because they gave us the first prize, the Innovation Award for PCBA and EMS.
Yeah.
Yes, indeed. It's a technology that has the throughput of the screen printers, but there's no mask. So you don't need to prepare a mask. And it has the flexibility and the accuracy of jetters and dispensers, but there's no nozzle. So nothing to get clogged. It's a completely non-contact deposition solution based on lasers.
Right. Okay. And what sort of materials do you put down? I mean, you've got a range that you can work with.
Yeah. So the fact that it's non-contact with no nozzles or anything like that allows us to go up to very high viscosities.
Mm-hmm.
So if an inkjet, for example, will go up to about 100 centipoise, we're talking about materials that can go up to 500,000 centipoise.
Wow.
Just to give you an idea of what that means, peanut butter is 250,000, twice the thickness of peanut butter. That's how big. And that allows us to print existing materials that don't require any kind of modification for our technology.
Right.
So if the material is being used today and it's been certified, we can use it too, as long as it's something that you can paste or something that's flowable.
So the example that we saw, both in the video you have on your website and also from talking to you at Productronica, was that you were doing PCBs. You were literally putting down all the materials, the copper layer, the solder mask, and then depositing the solder bumps on top of that.
Yeah.
So that's quite an achievement, and doing it at the speed of a stencil printer.
Yes.
Which is quite amazing. Can you do multi-layer PCBs, and what sort of parameters are you at the moment?
Okay, so anywhere along the electronic supply chain where one material is being deposited on another, etched, printed, sprayed, or whatever, we have a solution. But because there are so many different applications, we need to focus our efforts for each application, develop the process, and so on. We are currently focusing in the SMT world on depositing solder paste.
Yeah.
We're also working on some other applications such as die attach and underfill. Specifically for PCB, we're still developing the process, and we haven't fully developed it yet. We can already print single layers or even double layers, both the copper traces as well as the solder mask and legend and the surface finishing, but we're not yet there when it comes to multi-layer PCBs.
Right.
That's something we're still working on.
Right. Now, Ralph, your company IoTech is, of course, a startup company.
It still is, yes.
But you have attracted already two very, very significant investors in ASM Assembly Systems, which I believe own about 30% of the company, and Henkel, which I think are 10% investors. Is that correct?
Actually, I don't know what the percentage are.
You don't know the percentages, okay. Irrespective, I mean, but both companies are viewing your technology from a different angle.
Correct.
So if we can say ASM, for example, I mean, we don't want to give away too much, but they've already mentioned publicly that they're looking to change the face of material deposition at the printing process. Can you elaborate on that even just very slightly?
Well, ASMPT, as you mentioned, saw the potential in our technology because we can compete with their throughputs, but we're offering also the flexibility and the accuracy because we can control each individual drop of solder paste. We can print multiple solder pastes in the same run, or maybe solder paste and an epoxy when required. So this was very interesting to ASMPT, and they invested in order to be able to work together with us. There is a potential for maybe to OEM our solution, but we're still discussing that with them.
Right.
They have acquired one of our machines as well. So in addition to being an investor, they're also a customer. And they've installed our machine at their plant in the UK.
Right.
A former DEC plant.
Yeah, yeah. Yeah. Um, and is that technology? It's using like a carrier tape or something to.
Yes. So I'll give you a quick overview of how it works. So you deposit a flowable material onto a thin, transparent foil. It then goes through two cylindrical bowls to guarantee perfect uniform thickness. It's carried underneath the laser. The laser gives it a very brief, powerful punch, which creates a vapor bubble, pushing a drop of the material onto the substrate below. So the material itself isn't so affected by the laser. So there's no reheating. It doesn't work through melting or anything like that. Material properties remain exactly the same when they hit the substrate.
Right.
And this allows us also to control each individual drop at extremely high speeds. In fact, when I need to present it to customers, I need to slow it down 8 times, otherwise you don't see anything. It's just so fast.
That's incredible. And what about you, your other partner, Henkel? What is their approach?
So they love it that we don't require them to make any changes to the material. Give us a material that is flowable, and we'll print it for them. So they are constantly challenging us with their most complex materials, including two-component adhesives.
Right.
Don't try putting that through a nozzle; it will get clogged. Because it's non-contact, it's something that we can print.
Excellent. Well, it's extremely exciting technology, and I look forward to seeing the first prototypes coming out of something tangible.
So we're working with about 24 industry players at the moment, including back-end semiconductor players in SMT as well.
Right.
And we've already sold a few machines. There's a third machine. So Henkel bought a second machine. A third machine is going to a European semiconductor manufacturer who wants to use it for back end.
Right.
And we're already close to selling a few more machines this year.
Wow.
And we'll scale up for production machines next year in 2023.
Wonderful. Well, watch this space. It's certainly
Yes.
an exciting time for you. So congratulations and thank you for coming in and telling us about it today.
My pleasure. Thank you very much.
Okay, great. Coming up after the break, we're going to be talking to Dave Trell, who's coming in from Arch Systems.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand performance is directly related to ours. Science knows why it works, care knows why it's important.
Ko Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
And welcome back. And my next guest today is Dave Trail from Arch Systems. Nice to see you, Dave.
Hey, Trevor, how are you? Good to see you again.
Yeah, you're a long way from home.
I am. It was a little bit of a long haul, but the show is important enough for us to come out and spend time in the industry. And we brought a little crew with us this time, so some of the newer people with our company. And there's nothing quite like actually seeing the equipment and seeing the industry. And there's just so much that you pick up at these trade shows that you can't really get by looking online.
Absolutely. Okay. So Arch Systems. I mean, you really have made your mark as the provider of heavy data services for Flex. Flex obviously has a number of facilities around the world,
Sure.
And you're pulling data from all of these facilities, crunching it and putting out meaningful results at the end of it. Tell us a little bit about that
Sure. Yeah.
story.
Flex was really one of our very first customers that we started doing business with. And it's been great for both organizations because we were able to work very closely with them, and they've also had a little voice in how we've developed our product over the years and things like that. And it's been enormously successful. We're currently installed at all of their SMT manufacturing facilities worldwide. It's a little more than 40 facilities, and we have about 5,000 SMT machines connected into our system.
Wow.
Where we're collecting data. It's well over 1 trillion data points per month being digested within our system. So yeah, it's a massive amount of data that's being crunched and analytics derived upon that, and all these unique insights that you wouldn't necessarily be able to get without this volume of data that we're working with.
So that's a huge amount of data, but I mean it's ongoing and it's building up into this mass of knowledge.
Sure.
That is helping. It's going back down into the manufacturing process. Have you seen some real results in terms of productivity and reliability?
Sure. Yeah. We're some of the easier things that we're able to calculate is utilization. Is really one of the more impactful analytical insights that we're able to get, and that on a big corporation like that, we're talking tens of millions of dollars a year in annual savings, and then there's also things like attrition, and then once we start doing some quality correlations and with that large amount of data, you're really able to provide huge ROI and massive savings for these companies that need to these days to stay competitive.
Yeah, machine downtime has obviously been a big thing that's going to come out of this factory of the future type of thing. But I mean, obviously all the Flex facilities benefit from that, but from their own data. But that's not something that you share with anybody else. So what happens to the little guys? We need a system that's going to pull data from everybody,
sure,
and make it available to everybody who's subscribed to it.
Yeah, certainly, and as we mentioned before, that's something the industry has been talking about for a little while. Everybody wants to be the Google of manufacturing, if you will. And if anybody's poised for that, I would say Arch is. Whether I work at Arch or not, there's really nobody in the industry that's working with as much data and is able to process that amount of data in the timeliness that we're able to do that. So I think we're a little ways away from this Google of manufacturing type of thing, but certainly that's something on everybody's minds, and there'll be certain companies that get closer than others, but one of the key things that we need to look at that is everybody's still very secretive over their data, so we need to figure out a way to anonymize it. But certainly, it would be great in a future world where you could upload a circuit board design and say, what would happen in this type of process, and be able to debug before you actually run it. So certainly that's something that we're looking forward to.
I mean, you're talking about taking some baby steps though towards that goal by producing some modules. Can you tell us a little bit about these modules that you're...
Oh, sure. Yeah, absolutely. Obviously we just talked about a very huge concept of data. It's a very broad subject, and it's honestly it's big. To many companies, it's almost too big to really to bite off a chunk of that. Everybody wants this type of thing, but a lot of people don't necessarily know where to start. And you end up with stagnation on decision making because everybody wants to do these types of things, but where do I begin?
Right.
So as we started looking at our customer bases, we were looking at the people that use our software, and we noticed that there was almost a bucketization, if you will, where there's certain people in the quality department that are using our tool for unique analytics applied strictly to quality correlation and upstream detection and things like that. And then we also are doing quite a bit, as with the pick and place companies, and looking at attrition and time lost waiting for parts. And we noticed that there was specific parts of our product that are well tuned towards individual sections of most manufacturing organizations.
Right.
So rather than in addition to selling an enterprise solution, which is what we'll always be and we'll always do, where we're talking with senior management and trying to sell the process down into the manufacturing floor, we've modularized parts of our product where we're able to sell little pieces of that address a certain need on the factory floor level. Mm-hmm. That way people are able to get value out of it right away. Mm-hmm. And they're able to get ownership and provide benefits that directly affect them in addition to what they're doing for the broader benefit of the company.
Right. So let's drill down a little bit into these modular areas. You're talking about, for example, a module that will look at the inspection process. Mm-hmm.
Sure.
And then a separate one that will look at the placement process.
Yeah.
Is that how you're planning to roll it out?
It's interesting that you bring that up because there's segmentation, but we're able to break off a chunk, if you will, that looks just at some of the test analytics, and then there's some modules and reports and analytical evaluations that are done specifically for the placement. But even on top of that, you get more benefit once you start adding those two modules together, because then now you're doing quality correlation to your pick and place machines. Mm-hmm. So it's really building blocks that allow a company to use more and more of the product and grow with the product, in addition to getting the benefits of the broader Industry 4.0 thing that everybody's chasing.
Right. Yeah. The only thing I can see with that though, Dave, is that obviously there's a bit of a competition going on at the moment between the inspection people who want to control the line, as it were, and the pick and place vendors who also have line management software.
Sure.
And nobody knows at this point who's going to win that battle. But you've already got two big competitors in the ring.
Well, that's one way to look at it. And actually, when we walked into the trade show, when it began, we were looking at, there's a school of thought that the material handling people, because they touch every board, they should be the brain of the factory, and then the AOI guys, because the amount of data that they're getting, should be, the overlord, if you will. Arch really doesn't have a position that any one of those are competitors. I don't want to get that impression out there whatsoever, because we do want all of these equipment manufacturers to come out with the best software that applies to what their specialization is.
Right.
The Industry 4.0 talk that we've all been in for years has actually, there's been some bad fallout on this because there hasn't been specialization just in data and data management and things like that. And there's been a lot of people burned because, let's say, they try to go to a pick and place company that is selling, their MES type solution that works great for their systems, but then they can't necessarily do something with, AOI company X or screen printer company Y. And there's been a lot of false starts that have been initiated with that, and I think truly you need a software provider that provides a platform designed specifically for this type of enterprise solution that Arch is talking about.
Right. Yeah, I think where you're coming from is really that the Arch at the end of the day is a large data cruncher. You're able to handle really large data sets where other people are not, in that area.
It's actually much harder than most people think.
I bet.
Because it's not just collecting the data, very rapidly, but it's also manipulating that data in such a format that it's able to be contextualized on some level at that part, but also brought up into the cloud very, very efficiently.
Yeah.
Okay, and kept in its native format. So you get all the context and nuance that's in there, and being able to jump across those data points in multiple parts of the process across multiple products in near real time.
Multiple sites.
Yeah, multiple sites worldwide, near real time. It's not just something that anybody can do. There's a lot of intellectual capital that went into Arch on how we're able to do this, and it's part of what makes us unique in the industry.
Great. Well, we look forward to hearing more as it develops, Dave, and I want to thank you for telling us about it and coming in today.
Thanks a lot, Trevor.
Okay, thank you. Coming up after the break, we're going to have the third interview from live at SMTconnect. We're going to be talking to Stan Farnsworth from PulseForge.
Ko Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
And welcome back. So I'm joined now by Stan Farnsworth from PulseForge. Great to see you again, Stan.
Hi, Trevor.
All right, it's been a while. So you launched PulseForge essentially at CES earlier this year. You then followed that up with exhibiting at Apex over in San Diego. In between that, you've been looking at quite a few new innovations and methodologies for using the PulseForge technology. Bring us up to speed with what's happening.
Right, it's been a pretty impactful 6 months since CES, already not even 6 months. Mm-hmm. And what we've learned has been really helpful to help us understand how to engage and relate the soldering and thermal processing technology that we've developed. Mm-hmm. CES, of course, is amazing because it's really about products that are new and newly launched. And participating at CES put us in front of the right types of customers from the product design side and the product manufacturers, and what I'm calling sort of the apex designers who are setting the trends, on establishing trends, and wearables for our technology, both lifestyle and also medical wearables are a really, really big application focus for us. Automotive continues to be a big application focus for us, and then also more traditional consumer electronics. We got our start, our big production implementation years ago was making cell phone displays, and so most people have a display that was made with our tools in their pocket or in their house somewhere. So that's been it. So, but what we've learned in engaging in the SMT space, since we engaged with our soldering tools at CES, and then at IPC Apex on the manufacturing side, and then we exhibited at South by Southwest in Austin in March, which is not a technology show at all, but it is very much a creative design, creative energy. When you go there, if you come to Austin in April and March. It's a great time to be there before it gets too hot. But the energy around the creative design piece is really palpable. And so the gamut between the products at CES, the manufacturing at IPC Apex, the design energy at South by Southwest, and now here in Nuremberg back on the European manufacturing side with sustainability and the precision and the high quality engineering on the tools. It's given us this complete sort of understanding of the space.
Right.
And so we continue to engage on the manufacturing side because ultimately the manufacturers will be using our tools.
Right.
But increasingly now, our message is to designers that this technology that we're commercializing and have offered now in a tool form really changes the way that we think about design and being able to use different kinds of materials, different kinds of form factors. And we're encouraging designers to think outside the box because this technology enables them to push away the boundaries that have been limiting how they think about design and how they think about product innovation.
Well, I think certainly designers and OEMs are the areas you need to get to sort of get the message over about a new technology. I mean, you've got a sample here with you. I mean, just to show our viewers.
I do.
And this is basically some LEDs that are mounted on.
So this is PET polymer, really low temperature, lightweight.
Yeah.
It's not a particularly durable polymer from an electronics manufacturing perspective. This would never survive a traditional reflow oven. But what we've done is used our tool.
I'll hold that.
Thanks. Used our tool to solder SAC 305 solder onto it. Thanks.
Okay.
SAC 305 solder, and so now we have. Totally turned the wrong way here.
Yeah, we can see it even through the.
Yeah, so the solder, the lighting, we can see it.
Yeah.
You can't really see it. But the green LEDs that are soldered onto this in our process, it takes just a second or so to move through the entire solder process.
Right.
But it really changes how we think about design and how wearables, like I said, when they saw this at CES and through some of our other go-to-market engagements, they've gotten really excited about it. And so the Apex designers who are setting the standards, the Apex OEMs who are setting the standards on what their product visions will look like, this is something that speaks to them and they're very excited about it.
Yeah, I mean, because the key thing is that if you tried to reflow these LEDs on this in a traditional sense, it would just fry the substrate.
It would completely fry the substrate. It might melt the substrate and make a big mess.
Yeah, definitely. So your photonic soldering tool that you've got is basically can reflow this in milliseconds, really.
That's right, seconds or less.
Yeah.
We come from a space around sintering conductive inks on plastic.
Yeah.
So this is something that we've been doing for a long time, 10, 15 plus years. And the processing time for that is just milliseconds. And to go from sintering a conductive ink to reflowing solder is a little bit longer. It's a few hundreds of milliseconds, up to a second. But it's still a shockingly fast process, particularly in comparison to traditional reflow.
Great. Well, we look forward to seeing some of the ideas that come out of these design houses the next time we meet. But
we'll keep you posted. This is moving pretty quickly now for us.
Good.
Thanks, Trevor. Nice to see you.
Thanks, Stan. Okay. That's it for this edition of Live at SMTconnect. Coming up next is going to be our next panel discussion, which will be coming up after the break.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.
Ko Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.
Okay, hello and welcome to the first of our panel discussions today, Factory Robotics, Automation and Logistics. Some of the best innovations are coming out of European companies at the moment for factory automation, and here to discuss it is our eminent panel. To my extreme left we have Artur Topolowski from Fuji Corporation. Next to him we have Rob Rain from ASM Assembly Systems. Next to him we have Richard Vergesen from Yamaha. And of course, next to me we have Jürgen Reis from ASS Group. So welcome, gentlemen. Thank you for joining us today. I'm going to get right in with our first question because there's quite a lot we want to get through. And the first question I'll give to you on the end there, Arthur, and that is, with supply chain shocks and labour shortages throughout the industry, how important is it to implement a factory automation strategy as part of your digital transformation?
So yeah, as a current trend I observe in the market is that all the customers we visit, the volume increases. Hello?
Oh, I'm sorry, we've got a problem here.
Is it better now?
Is that working?
Yeah.
I think it's working.
Hello?
Yeah.
Yep. So, sorry. Automation plays a crucial role in today's world because, as we know,
we need the monitor speaker up.
Increases in Europe of electronic manufacturing, and all companies looking for better and more efficient way of manufacturing. Therefore, we as a Fuji responded with a new platforms. We released an XTR-A automatic machine with 0 defects, 0 stoppages, and 0 operators. It's fully automated system. We also released automation in through-hole area with 3 machines: SFAB Alpha, radial axial wire inserter, SFAB D odd form platform, and Smart Wing board assembler, which can take random packages and place them as an operator would. So this plays a key role in automation. At the same time, we released a new platform of our software, and this way we can utilize operators more and automate. Sorry. we can automate more processes operators used to do.
Right. Okay. Robin. Okay, carry on. Same question to you, really. I mean, what do you think we can do to implement a factory automation strategy using digital transformation?
Well, I think a critical part of the supply chain these days especially is being able to plan ahead. It's getting so hard to know that you're going to have the components you need when you're going to need them. Right. An automated system that can help you suddenly change your plans when a is not going to be there tomorrow, to be able to redesign or rearrange your delivery schedule using automated systems so you know exactly what you've got available on the shop floor and what's in your stores, and be able to plan to that level of detail that you can immediately change the plan and then back again later.
Yeah, I mean, Jürgen, I think Rob's absolutely right. I mean, up until now, we've been working with a just-in-time sort of model. Nowadays, with all the supply chain shocks we have, a lot of people are holding more inventory. They've got to be able to plan ahead. You're in the business of working with component storage and supplying and stuff like that. What's your take on this?
Well, as the colleagues just said, the visibility of your parts, to make them available actually everywhere on your shop floor, to have the planability, these are the key effects. So it's always a symbiosis between the hardware and the software, and then it comes to the point, it's not just the component roles, there's so much other kind of material you have to handle in the shop floor, and then it's the question about which capability you can deliver for us as an automation company to our customers. So the approach is an open software system. It's capable in a hardware way that you can handle every kind of application on the shop floor, and then it's tailor-made to what you need. But in the end, availability of parts, planability, and get it in the right time to the right place. And if customer wants to fully automate it, that's the package you have to deliver.
Okay. While I've got you there, I mean, how easy is it to program and implement AVIs to move materials around the factory?
Oh, that's common technology. I mean, you have open interfaces, standard interfaces. So for us, AAV is just one way to move material around, and we can offer it to the customers, or they have their own fleets. For us, it doesn't matter if it's from vendor A to B to C. We integrate it with open software, and if customer wants an AAV, it's
Yeah.
common technology.
Common technology. Okay. Richard, we haven't heard from you yet. So how easy is it, from goods inward till the time the reels are loaded onto the pick and place mounter, what processes should manufacturers expect to optimize or eliminate, and what KPIs should they be measuring?
For further factory automation and line efficiency, we are looking into the feeders, how to make it easier to replacing reels without stopping the machine and get the supply at the right time. KPIs, you're asking.
Yeah, I mean, what KPIs should they be using to measure their performance, basically, their process?
With the OEE analyzing, showing directly to the operators the actual performance, and with all the indicators like peak performance, vision recognition, and line efficiency, and with the quality from the AOI, you have the KPIs to manage and to improve directly with all the data which is behind and visible with a dashboard,
right?
In graphs to easily understand and feedback to the machine, so operator knows exactly what to do at what time.
Okay. All right, we'll move on to the next part of the process. And Robbie, is a bit of a trick question for you. Is a multi-stencil capability a must-have for modern high-mix factories?
I think it's a very useful possibility. I think that the main thing it does is it decouples that operator intervention from the changeover. So it basically allows you to preload your printer with the next setup so that when the next board comes in, it can change over automatically. It's very important, though, to make sure that you've got your printing process set up correctly in the first place, because in general, it's not going to be as simple as changing over a stencil only unless you've got everything else under control.
Yeah, I mean, that's right. I mean, Jürgen, you're in that business. You've got a stencil printer that does change over, but it's not just a stencil. You're changing the paste and a lot
squeegees.
of the squeegees as well.
Yeah.
So you really need to make it completely operator free. You need to be able to do all of these different areas for sure. Okay. Let's see. Arthur, with increased miniaturization in large components located next to small devices, what technologies are needed to achieve paste volume deposits?
There are a number of options available, like step stencil, additional paste dispensing. We can place additional solder shapes onto a PCB to add more paste to create a solid joint to a larger component.
Okay. Yeah, I mean, step stencils is certainly an option, not particularly common. Should I say likable one? People don't particularly like step stencils, but yeah, it's certainly an option. Okay, let's see. With increased, is automated feeder bank changeover only suited to high volume manufacturing? Again, I'll give that one to you, Richard.
No, definitely not. These days, especially small batches, a customer is optimizing or purchasing a line depending on a certain volume, and you have boards with less components, more components, and you creating a line which has maybe for 50% overcapacity, and for the rest it's okay. So you optimizing all the programs in one setup as much as possible to have no changeover on feeder cards. But for next second set of products, you only need to change maybe 2 or 3 in a whole line to quickly change over for another batch. So with grouping software and feeder exchange cards, you continuously the process without stopping the machines, especially these days in Europe. It's more of with EMS companies, small batches. This is the way forward.
Yeah, no, I agree. Rob, would you agree with that? I mean, I think being able to shave machine downtime, get quick changeovers, that is really where you're going to make the big savings, the big changes when you with automating your factory process.
Sorry, Trevor, I didn't quite catch that.
I'm saying that saving machine downtime in changeovers and things like that, that is where you're really going to make gains in your factory automation process.
Yes, that's absolutely right. And the more work you can do in one go, changing over whole feeder banks, that can be a benefit. But you do have to plan your whole production process around the strategy that you choose. It's not something you can just do one day in one way and another day in another. You've got to think quite a way ahead, especially in something like high volume, where replenishment is the key factor that you need to think about. How do you have a process that or empties a whole bank of feeders at once evenly to make it efficient to change over, as opposed to 3 feeders are out of 60 and now you exchange it? That doesn't feel efficient.
Okay. So Arthur, what's your view on automating feeder bank changeover? I mean, you actually have a robot system that works with your pick and place system. So that works efficiently for whether you're doing high volume or high mix.
Yes, the idea was to production lines. We are currently developing a system that's going to integrate component storage system with handling materials, loading them onto a vehicles that are going to feed the line. So in theory, you just need one operator to run 5 lines. But with currently changing a feeder pallet, there is an option as well. However, there is a possibility of replacing feeders for while machine operates. So we can have 2 products at the same time. Product A is being manufactured while feed is being put for product B. And then this way, there's another method. There's no changeover, seamless changeover. You change from one job to another because you set up during previous job operation.
Okay. So, Jürgen, let's come back around to you. I mean, what do you think, in your opinion, are the most efficient ways that small to medium manufacturers can optimize their process today if they're starting down a factory automation, digitization route?
Oh, that's a big question.
I know, but you've got a lot of answers to it.
Well, if you look at our portfolio, yes, the point is, I think you need to choose the right level, what you actually can handle. Because one is a CapEx question, the other thing is how good you can handle it. Because you need a technical team in your factory which can handle the technology it gets. And our approach to this one is open in the scalable solutions. Whatever we do on a hardware, on a line level, in terms of autonomous capabilities, you can start with a very simple version, but always have a capability to upgrade it because it grows with your demand in terms of capacity, what you can allow and to afford in your investments, and as well what capabilities you have. Because if you want, you can have almost kind of lights out factory. Yes, possible, but for sure you need to be capable to manage it. So try to find something which fits in your strategy, how you plan your production. Try to get solutions from the different vendors, which some are flexible in the way you can use them. They can breathe with the way you grow your capacity in the future. So that's the approach we tried. You can go to the very high end, but you can start also with an like, let's say not entry level, but with an let's say reasonable level, and then you get up in capabilities, autonomy level, and in all the features you need around.
Okay. Richard, if I can come to you, I mean, you've got a fairly efficient line system for factory automation. You don't have much in the way of the getting the materials to the line, do you? In terms of bringing components from goods inward through storage, through component counting or back and to the kitting area and back from the.
Yeah. We're developing our AFV, autonomous factory vehicle. which is showed at the IRX this year at Tokyo show. So we are looking into our portfolio to add also autonomous vehicles for factory, for indoor, outdoor, so in different levels, low speed, higher speed, and also in volume, be able to get the supply of factories, not only for SMT, but for the whole factory automation for any business.
Handle everything.
Yeah.
Yeah. Okay. Rob, I mean, you've got a fairly integrated system all around at the moment. But how important is it to also digitally manage the human capital within the factory?
Well, I think as we move forward with automation, it is really important because automation is best focused on the repetitive tasks. And the repetitive tasks are what we as humans are slightly less good at doing without error.
Right.
So as you transition your workforce away from the repetitive tasks that are good for robots, you need to think about what they're going to do instead and how that human imagination and that human ability to solve a problem by going around corners is going to work. Mm-hmm. And recognizing those people, managing their skills and spreading them across your shifts, especially if you're running a 24/7 operation, you don't want one shift to have a missing skill when you've only got a few people.
Right, absolutely. Okay. All right, we'll finish off with Arthur. I mean, what improvements are you making onto the Fuji system for the factory automation and your line control software?
I'm really sorry.
You can't hear me. Okay, we'll finish off with you. What improvements are we making at Fuji on the factory automation side and on the line optimization software?
Yes, we have a scheduler which is helping to spread your human resources accordingly to your needs. We have material management part of our Fuji software as well that helps to allocate resources where are needed. And we have a multi-job line balancer as well as part of our software that can combine a lot of jobs in one list and then plan meal production for you. So you basically, you can kit your material for 3-4 days ahead and use it this way to utilize people when needed.
Well, gentlemen, I think we've come to the end of our session here today. I want to thank you all very much for taking part. I know we've had some issues trying to hear each other, but I can assure you that you're going to hear it very clearly when you play it back tonight. So for now, I'm going to say thank you to Arthur Topolowski from Fuji, Rob Rain from ASM Assembly Systems, Richard Vergesen from Yamaha, and Jürgen Ries from Asus Group. Thank you, gentlemen, for coming in today, and thank you to our audience for watching. Our next panel will be coming up at 4:15 today, and that's on energy reduction and sustainability in the EMS process.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.
His English was being asked, and we asked him a couple of questions that he couldn't answer. We'll edit it out. We'll tidy it up the best we can. I know. I mean, Daisuke's predecessor, Arimoto, he speaks good English. I know, we always like to be in front. and welcome to our second panel of the afternoon, Energy Reduction and Sustainability in the EMS Process. Government mandates for energy reduction and industry demands for greater sustainability and driving manufacturers to look for new and innovative strategies to reach these goals. This panel will examine the range of new initiatives to reduce energy cost and the carbon footprint around the factory. I'm joined today by Peter Franklin, to my extreme left, from BTU, Florian Graf from SMT Thermal Discoveries, and of course Gert-Jan Diepstraten from ITW EAE. So thank you for joining me, gentlemen. I'll get straight in with my first question today, which is, will the EU decision to ban oil imports from Russia make European EMS companies less competitive?
I think probably not, Trevor. I think, is this on? Okay.
Yeah.
I think that in the long run, this will drive the EU and the whole of Europe towards greener, more sustainable forms of energy, which will benefit us all. In the short term, there may be a very small impact, but I don't think that it's going to be significant, personally. And I think that if we can wean ourselves off the dependency on fossil fuels, then it's got to be a very good thing for the future.
Right. I think, Florian, I don't know if you think about that, but I mean, don't you think it will depend very much on how fast that they have to wind down the dependency on oil, for example? If they give us to the end of the year, as they're talking about, then that might be achievable. But if they try and achieve it much quicker than that would cause a problem.
I could not understand you right. You mean the carbon footprint?
No, I'm talking about the first question was really on the oil.
The impact of the oil.
The impact of the oil. Is that going to affect EMS manufacturers in Europe?
I think that has definitely an impact in Europe, for sure, because you see it already today, the jumping prices, it's very high. And but I also see that also a corona topic is coming into this game, and you see that the regional thinking is also strengthened. So I think that the energy prices can be also have an impact, but also the impact of the corona crisis, that the people want to produce more in the regions, in the region, also in Europe. So, and then it would definitely rise the cost, but it will also drive the economy in Europe, I guess.
Yeah, I think you're right. Gert-Jan, I mean, what strategies can oven manufacturers pursue to sort of make ovens consume less energy?
Yeah, first of all, you can improve in your design, because what you want to achieve is the best throughput with the lowest energy consumption. So if you have a good heat transfer, your overall temperatures in the oven will be lower. Then the other thing what we can do is, for example, what we do is with sensors, we look up the line, see if there's maybe maintenance or lack of production coming. We can switch off, reduce the machine power, so we will go in idle mode, so save a lot of energy there. And the other thing, of course, is if you have the ability, if you have a dual lane, you have, instead of 2 ovens, you have 1. So you consume per PCB a lot more energy as well.
Right, okay. Peter, anything that you would add to that in terms of methods for manufacturers to reduce energy in the reflow ovens?
Well, I agree what's been just said, that most production lines are not running production all of the time, or not running product all of the time. Yeah. And so a huge benefit can be got from a sustainable and very efficient idle mode for the machine. And we've developed a lot of both software and hardware assets to help that.
The problem is it takes so long to get these ovens up to temperature that you probably have to just drop them slightly, so they're not running as high, so that you can ramp them back up.
There's a number of things, not only dropping the temperature, but also the fans that are running a convection system are a significant impact on the power consumption, and they can be reduced or switched off completely without affecting too heavily the recovery time.
Right, okay.
I see the same with the fans. The fans are the most usable, let's say, consumer in the oven. I would say it's around 50% is coming from the fans. And so you need to reduce the energy consumption of the fans. Right. And the reduce of the temperature, I don't think that this is so critical. I would say even the opposite. I would say we need to think on doing the profile in another way. We need to go a little bit higher on the temperature to reduce the convection, and then you have the same effect on the profile. And you can save around 10-20% of your energy with the same profile. And this is the thinking of, let's say, going on doing a profile in another way and trying to set the temperature as less as possible. So it's always good to have a temperature setting, and you can run most of your products with one temperature setting and only change feed speed, for example. That help you have a very good impact in using in energy consumption, let's say.
So your thinking is to use these more intelligent blowers that a lot of companies are installing into reflow ovens now to control the temperature, pretty much leave the heat at the same level, but control it using intelligent blowers.
Yes, definitely. The big target needs to be to have only one temperature setting, and the rest you will do with the convection settings.
Okay.
And then you avoid also changing of temperature. That means waiting time is less, and you also need to heat up and cool down, and heat up and cool down, even slightly temperatures. So even if it's only 20 degrees.
Yeah. Okay, that sounds reasonable. Gert-Jan, what strategies can EMS manufacturers take to make their factories more sustainable?
Yeah, first of all, I think I have to look at the PCBs. You have SMT components, and you may have some through-hole components. So what you're going to do with the through-hole? Are you going to do pin and paste so that you can eliminate another process step? So you don't need a wave solder machine or a selective solder machine. But then you have to invest in more expensive components, but that is a choice, which makes it more sustainable. Then the other thing you can do is group your components, as Florian also explained. If you have one profile for many PCBs or with different conveyor speeds, you don't need to go from one recipe to the other recipe. So you save a lot of energy as well on that part. So yes, I think also then you have to see what is the layout of your factory. Can you do more dual lane? Then you save also more energy as well.
Okay. Peter, have you got any thoughts on what other strategies EMS manufacturers can use to make their factories more sustainable?
I think that I agree with what's just been said, that dual lane systems are a huge advantage in this respect, and also I like it's a good idea to try to minimize changing control parameters on the equipment. So if you can run a single profile or a single temperature setting and then make adjustments using conveyor speed or more often convection control, it's important to have very accurate closed-loop convection control in order to be able to do that, in my opinion.
Right. Okay. Florian, let's see. Will the desire to consume less energy among manufacturers, is that likely to drive more companies to use things like low-temperature solders?
It's definitely an interesting topic, but I don't think that it's a solution for everybody. I think you really need to look at the application. What is the application? Is it in an environment with high temperatures? And if it's, let's say, in a car, I think it can be difficult. Yeah. I think for the consumer, it can be definitely an option for the consumer electronics, and it's definitely you need less energy. But also there will be other, let's say, challenges you will face on. So I think it's a topic, but it will go very slow in this direction. Also, if you see new validations, how long it needs to get a to get a solder paste running and the validation for that. It needs a long time. So it will be in small steps, but I would say in the consumer electronic it can be definitely an option.
Well, I mean, it certainly brings some benefits. I mean, it's reduced energy, reduced costs, increased reliability of the electronics.
Yes.
You know,
Yes, definitely that is that's correct.
Yeah. Any thoughts on that, Gertrude?
Yes. If you look at reflow, you're correct. If we can reduce the reflow temperatures on the peak end, it saves a lot of energy there.
Yeah.
If you look at, like for example, the other process, soldering process, the selective soldering process or the wave soldering process, most of the energy in those processes comes from the preheating. So you do not benefit so much of having a lower solder temperature, because keeping the solder temperature stable at a certain temperature. If it's 240 for low temperature solder versus 320 for lead-free, the consumption in energy is not that much. So the benefit is there for getting an easier tool fill, from a process point of view, and cheaper materials, especially plastics and so on the component and board side as well.
Well, typically LTS materials are cheaper, but
Yes.
it doesn't always filter down to the customer.
That's true.
But okay, I'll move on. The next question I've got, Peter, what is the optimum way to achieve an even delta T across the board?
Well, I think this comes back to fine control of the convection flow rate. This is the way that you get very even temperature spread across the board. We use convection because below the red heat spectrum, it's by far the most efficient way to transfer energy. And if you can control that convection flow in a closed loop fashion particularly, then you can get a very even temperature spread across the product. And that's the way to achieve what you're trying to achieve and give yourself the maximum process window.
Right. Okay. I mean, I remember a number of years ago, there was a company, VI Technology, who produced a reflow oven where the board came in to each zone and the doors closed around it, and you got a really good even delta T. It opened up, it went to the next zone, and it did the same. But the problem was the machine was over-engineered. It was just too expensive, and nobody would buy it. But I'm just wondering if there's been any modern equivalents, apart from, as you say, trying to control the airflow to get a better even delta T.
I think in a way you could say that the move or the interest in vacuum is a version of that. It's it gives you a very good result, and of course low voiding if any voiding at all.
Yeah.
But there is a price to pay, and you've just described that price. You have a very complex system which is expensive and slow, relatively.
Yeah. Okay. So next question to you then, Florian. What is the in fact, I'll give the same question to you. Have you got anything to add to that on the even delta T?
Yeah, for delta T, I would say time is always helping. That means if you have the time to go a little bit slower, that always helps to get the delta T together. Yeah, so this is. But if you don't have time, I guess you need a very good heating transfer. Yeah. That's the key.
Yeah.
And of course a good cross profile. So at the end there is not a secret. Yeah. But if you have time, it helps. It helps the most.
Yeah. Makes sense. Yeah. So my next question, I'll just stay on you for a moment, Florian. That is, what are the pros and cons of vacuum versus vapor phase for peak reflow to reduce voiding?
Yeah. I would say the vacuum reflow, of course, have a much higher cycle time. So that means you can be much faster in doing the same process. And also regarding maintenance, it has more the advantages regarding a reflow oven. So you have less work less maintenance to do.
So what type of vacuum are you talking about? That's just pure vacuum versus vapor phase. So you think vacuum is quicker?
Yes, in the vacuum reflow process is a quicker process.
Right.
Because you can go inline, you can go in a dual lane version or even in a triple lane version. Yeah. And so it's a much cleaner process. and it's a process you know already in your SMD, so it's not an additional, let's say, process you get in your production. Yeah. I think a vapor phase is very interesting if you look at small batches, if you look at very, very high and complex products. But for standard products, for ambitious products, I think vacuum reflow is a process where you have better under control and where you can be faster with a higher throughput.
Right, okay. Georgia, anything to add to that?
No, I agree with them. The only thing is, if you consider vacuum reflow, you have to also look at how much of your assemblies you want to solder in vacuum. So if
how much of your assemblies you need to
do vacuum soldering, instead, maybe you have only 50% of your boards that you want to go to do a vacuum process, and then you have 50% that you want to do traditional soldering in the same oven.
So that's a good question. I mean, is that possible? I mean, that you can just do a straightforward reflow soldering without vacuum in a vacuum oven?
Or maybe you can answer better.
You can do.
Yeah. The process you can choose if you need it, if you use it, or if you do a reflow process.
Right.
This is let's say, saved in your profile. That means you can even run in a mix if you want.
Right. Peter, last word to you. Any thoughts on vacuum versus vapor phase?
I think I'd agree that with standard processes, the vacuum reflow is the solution. If you're looking for low voiding, then it's definitely the way to go. But if you have mixed products, some particularly heavy or awkward, let's say, products to process, then I think vapor phase comes into its own probably.
Right. Okay. Some interesting questions there. So let's see if I can add in another one. I need to get my questions here. So what is the best flux management strategy? Well, that's a good one for you, Peter. You're involved in that. So let's talk about a bit of that.
Okay, well, at the show this week, we have the AquaScrub, our flux management system, which we're recommending, and it's a unique solution, I think. It uses a gas wash using an aqueous solution and a rinse, and it removes 90% of flux from the process chamber without significantly increasing the power burden on the oven. So I think it's a very efficient way to do it.
Well, it's certainly an answer to a really sticky, messy problem, that's for sure. Florian, any suggestions on flux management?
Yeah, the flux management system, I would say you need to have as short distance as possible. That means if you take out your process gas for cleaning, you should have very short ways, the best without any tubes. And also it's very important that you clean more often, not in a big one, in a big setting, so more often in every zone, for example, because then it's a more efficient. And also you should take into account the temperature. So for example, if you are in the entrance, you can still use a condensation trap, but if you go into the hot zones, you should go on a hot cleaning system. That means the pyrolysis cleaning. And if you then come again to the cooling zone, then again you would need to do a condensation traps, let's say. And this also saves, of course, energy, because in the heating, if you use the pyrolysis system, you can use this energy also again for your oven.
Okay.
And so I would say clean small steps, do it very short distances, and take care of the temperature and use the most efficient cleaning, in this case, temperature.
Seems a fairly good answer. Have you got anything to add to that? Or do you...
I agree with Florian. What we also do in our machines is have the cleaning in each zone, so you don't need to transfer all the gas through the pipelines to a cleaning station. So we use catalyst instead of pyrolysis. The advantage of catalyst is that it only needs 280 or 300 degrees instead of going to 500 or 700 degrees to make the cracking of the volatile parts. So local, as Florian mentioned, I think with the lowest temperatures. In the past we did condensation. Condensation, you take the hot gas and cool it down to very low temperatures, so that costs a lot of energy.
Yeah.
So that's how we try to save energy and keep the oven as clean as well.
Right. Okay, so there you go. A few alternatives for flux management. Last question to you, Peter. First of all, I'll ask the others afterwards. What is the best nitrogen strategy? Supplied in bulk tanks or using a nitrogen generator?
We've been through the cycle of nitrogen generation many times, but it's expensive to produce pure nitrogen in that way, which is why most people favour a cryogenic system, a bulk system. I don't think it should be ruled out, because the more we push at generation, the better that process will become, and eventually perhaps it will be competitively priced. Right. But at the moment, if you want to deliver very pure nitrogen to your equipment, I think probably in most cases, bulk system is still the solution.
Still the best. Okay. Would you agree with that, Florian?
I would say yes. So in the standard industry, if you have the high throughput, if you have a lot of production, and this in a very fast way. Yeah, so if you flood an oven, for example, if you start up, you need a lot of energy, a lot of nitrogen to get the machine in the ready state, to go on a 500 to 1000 ppm. Yeah. And this to do with a generator is a very high effort. So the generator in this particular moment has to be very big to deliver this. So I think it depends a little bit on the expectation, what you have. Do you want to go on 500 ppm or 1000 ppm, or do you agree with 2000 ppm? Then it can make sense to say, okay, perhaps the generator is the right decision for me. But I would say in the EMS, where we talk about a lot of volume, a lot of production, I would say that it's definitely the bulk. Yeah.
So you would say in EMS definitely better with the bulk system. Yeah. Okay. But a nitrogen generator
for high volume, I need to say. Yeah.
High volume. Yeah. Okay. But for low volume, high mix, you would suggest that the generator might be the best route. Is that what I heard you say?
Yeah, it a little bit depends then on your expectation. If you really run at 500 ppm, you also need a very pure nitrogen. Also, it needs a very long time to come to that level. Mm-hmm. But if you agree on 2000 ppm, which also can help you already, then it can make more sense to say that this is the right decision. So it's a little bit on the expectations you have to your process. What is your target to achieve? But if you talk about EMS and high volumes, 3-shift production, and it doesn't matter if it's high volume or low mix, or then I would say it's really the bulk. Yeah.
Okay. Well, I see you nodding away there, Gert-Jan. So I'm guessing that you're agreeing with most of the things that Florian's saying.
I more or less agree. For reflow soldering, it's you need a really high capacity to get a low ppm level. We also have selective soldering, where it's different. The nitrogen consumption is much less. Yeah. And for that, I think it's more interesting. And you see also more in the field that those companies use generators. If you look at sustainability, a generator is also consuming energy. Yeah. It also makes noise, needs maintenance. So it has also disadvantages. On the other hand, if you have a tank, you have to transport all the gas two times or maybe 3 times a week. So that comes also with transportation costs and so on. So. Yeah. And the advantage of a generator is, if you need the nitrogen, you can produce it. If you don't need it, you switch the machine off, the generator off.
That's true. That's true. Well, gentlemen, I think we've had some good answers there. We've talked about some interesting topics around the business of thermal reflow. So I want to thank you for your contribution in coming in today. Peter Franklin from BTU, thank you.
Thank you.
Florian Graff from SMT Thermal Discoveries, and Gert-Jan Diepstraten from ITW EAE. Thank you for coming in, gentlemen, and thank you to our audience today for watching. That brings us to the end of our panel discussions today from SMTconnect.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Ko-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge. In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.